Okay, so we are looking this time at the last two examples. These are the more complicated examples, so I wanted to make sure that you had these at your disposal to watch and take notes about. We're going to have to approach things a little differently and actually use the third equation that we normally haven't been using up to this point. So let's look at part A. We've got this cannonball being fired here, 50 meters per second at a 30-degree angle. This is 40 meters right here above the ground. Okay, calculate the maximum height of the cannonball. First thing we need to figure out is what's going to happen here. It's going to fly up, and then it's going to come back down and hit the ground somewhere over here. So this right here, this distance right here is going to be our delta x. Max height's going to happen somewhere up here. So the first thing we need to approach is think about what's happening at that max height. We know that v initial, this is in the y direction, is going to be 50 sine 30 degrees. That's going to be 25. We know that v final right here in the y direction is going to be 0. Okay, that's what's going to allow us to figure out what that max height is. So let's approach it from that standpoint. So we're going to look for the maximum height. We know v initial in the y direction is going to be 50 sine 30 degrees, which is 25. We know v final in the y direction right there is going to be 0. We know a in the y direction is going to be negative 10. What we don't know is time, and I don't want to have to find the time. What I'm looking for is delta y. We don't know what that is, but we're going to figure it out. Because what we're going to do is figure out what this delta y is, and then we're going to add this 40 meters to it. Okay? So delta y is just going to be this chunk right here from where it starts to where it goes. So what is delta y? Well, delta y, if you remember, we don't have time, so we can't use the formula we normally do. So I'm going to actually use the third formula, which is v final squared equals v initial squared plus 2a delta x, or in this case, delta y. We know this is 0. This is 25 squared plus 2 times negative 10 times delta y. Okay? So when we solve this, work out the algebra and solve it for delta y, what we get is 31.25 meters. Well, that's all well and good, but what we're going to add to that is the total max height. So our max height, as we looked before, is going to be that 31.25 plus the additional 40 to the ground. So its max height is 71.25 meters. There's part A. Now in part B, we got to find the horizontal distance. To find the horizontal distance, we do need the max time. Okay? So we need the maximum amount of time. So I'm going to use y, the y direction to find the maximum amount of time. So y initial, and this time, y initial is right up here at 40. It's sitting up at 40. Y final is going to be at 0. Okay? So y final is at 0, because this is the ground. Ground is at 0, so this is 40 and this is 0. All right, we know a sub y is equal to negative 10, and the velocity initial of y is going to be 25. We found that earlier. Meters per second. This is meters per second squared. This is meters. So we're going to do what? Time. So delta y, which is this time negative 40, is equal to v initial t plus 1/2 at squared. So this is v initial is 25 times t plus 1/2 times negative 10 times t squared. That gives me negative 40 equals 25t minus 5t squared. This is a quadratic, so I need to move everything to the other side. So I get 5t squared minus 25t minus 40 equals 0. That is not factorable. I'm going to divide by 5. So I get t squared minus 5t minus 8 equals 0. And then you can really see it's not factorable. Since it is not factorable, we have to use the quadratic equation. If you don't remember the quadratic equation, in this case it would be t equals negative b plus or minus square root of b squared minus 4ac all over 2a. So my a is 1, that'd be in front of the squared term. My b is negative 5, and my C is -8. So this is A, this is B, and this is C. So we're going to plug this in. So we get time is equal to -5 plus or minus square root of -5 squared minus 4 times 1 times -8, all divided by 2 times 1, which is 2. Put that times 1. So we get 5 plus or minus square root of 25 plus 32 divided by 2. All right. So what I get is like -1 point something, which I can't have because I can't have negative time, or I get positive 6.3. So time is 6.3 seconds in flight. Now, how does that help me? Well, what that allows me to do is now find delta x, which is equal to v initial in the x direction times t plus 1/2 at squared. Well, that goes to 0 because the acceleration is 0. So this just becomes 50 cosine of 30 degrees times t, which is 6.3. So I end up with a total of 272.8 meters away. So that's part B. Now, part C. Part C is now asking us what? Calculate the velocity at which the cannonball hits the ground. Okay, so the velocity at which the cannonball hits the ground, if you remember, it's going to be coming in at an angle. This is V final. So we have to find V sub y final and V sub x final. We already know V sub x. So V final is equal to the square root of V sub x final squared plus V sub y final squared. Well, V sub x final we know. It's the same as it is initial, which is 50 cosine 30 degrees, which I believe was 43.3. V sub y final is equal to V sub y initial plus AT. Okay, so that's 25 minus 10 times the 6.3 seconds it's in the air. We get -38 meters per second. So now we're going to take this and plug them in. Okay, so V final is the square root of 43.3 squared plus -38 squared, which gives us a grand total of the final velocity being 57.6 meters per second. Now that one was tougher, and mostly it was tougher because of the quadratic equation, but you can do this. All right, so let's move to the last example. This one's actually a little bit easier. We want to know if when this thing is shot, does it make it over the fence or does it hit the fence? Boom. We don't know. So what we have to figure out is we've got to figure out what the actual delta y is and then compare it to 2 meters. Okay, so that's what I'm going to do. So I'm going to use delta x this time to find the time because they gave us this 16 meters, didn't they? They sure did. So I'm going to say delta x is equal to v initial in the x direction t plus 1/2 a sub x t squared, which we know is 0 because a sub x is equal to 0, right? So this is 16 meters. V initial is 14 cosine of 30 degrees, right? Times t. Well, t, it turns out if you divide, is only 0.495 seconds. So now what we're going to do is we're going to check delta y and see if it makes it over that fence. Delta y is equal to v initial y times t plus 1/2 a sub y t squared. Well, we know this is 14 sine theta, which is 30 degrees, times t, 0.495, plus 1/2 times -10 times 0.495 squared. So this is 7 times 0.495 plus, or minus, excuse me, minus 5 times 0.495 squared. Turns out that is 2.24 meters. Well, that is bigger than or greater than the 2 meter tall fence, isn't it? So what happens? The football clears the fence. Okay? And that's it for those examples. What I want you doing now is I want you to finish your homework assignment, which is, I believe, 2.2, number 7 through 14. So you have a bunch of these additional harder problems to do in using projectile motion. Good luck, guys. Bye.